This is section 8.7, complex numbers. I've been teasing this the entire chapter. We are going to learn how to deal with square roots of negative numbers. Not any other even root of negative numbers, although it is related to what we do here. But we're just going to be talking about simple square roots of negatives. And your calculators in general cannot do these problems. So you do have to be smarter than your calculator, okay? We call the variable I the imaginary unit. Now this word imaginary is unfortunate because these are legitimate numbers. This is a legitimate field of mathematics. There are entire courses built around complex numbers. Okay, I took complex analysis as a senior level class in college. Okay, but I is the imaginary unit, and by definition, I is equal to the square root of -1. Okay, definition, there's no y here. This is the variable we use for this. Okay, now if you can imagine squaring both sides here like we did in the last section, you'll get I squared is equal to -1. This is critically important. We use this all of the time. Okay? In fact, any time we have I raised to an exponent, we can always simplify that. So we're going to be dealing with that in a little bit. Now, the main property that we use for complex numbers or imaginary numbers is if you have the square root of a negative number, then you can put an I on the outside and then you take the square root of the positive number. Basically, I say pull an I out, and since it's a nice little pun there, it sounds kind of gross and it's easy to remember. Okay? Now, let's just get some practice with this, simplifying the following numbers. Okay? I have the square root of -255. Well, the first part of simplifying this is to take that negative, and when you put an I on the outside, and then it becomes the square root of 255. So that much simplification has to be done no matter what. Now, of course, we simplify the square root of 255 if we can. And you can use your calculators, or you can do a prime factorization. If I do the square root of 255, I hope my calculator can do it. And it just says it's square root of 255. That means that doesn't simplify at all. If we did a prime factorization, what would we get? We would get, if I do the prime factorization of 255, okay, it's divisible by a 5. And when I do that, I get 51. And then 51 is divisible by 3. Remember your divisibility rules. If it ends in a 5, it's divisible by 5, of course. For 3, if you add the digits together, in this case I get 6 when I do that. If 3 divides evenly into 6, then 3 divides evenly into 51, okay? If I do that, I get 17, which is also a prime number. So this prime factorization is 5 times 3 times 17. I don't have any pairs, nothing simplifies, okay? So that means this is as good as that answer gets. It is simplified, okay? If I want to simplify the square root of -21, I pull an I out and I get the square root of 21. Now I would check to see if the square root of 21 simplifies. If you think about doing a prime factorization here, you would get 3 times 7. No pairs, that's as simple as that one gets. Okay, so let's talk about doing some other calculations with them. Okay. We're always going to simplify before we multiply things together. Remember that our radicals, anytime we have a radical, we can write it as an exponent. And so that means that radicals, calculating the radicals, falls under the exponent step of an order of operation. Okay? So we have to calculate the radicals first. Okay? So if I take the square root of -9, that's equal to I times the square root of 9 times the square root of -81 would be I times the square root of 81. Now both of these simplify. The square root of 9 is 3, so I write 3i. We put the I in front of a radical, but if we're able to simplify it completely, we treat it more like a variable. We put the 3i, okay? Similar here, the square root of 81 is 9. So this is 9i. Okay, so let's treat this like it's a variable. 3 times 9 is 27. I times I is I squared. Now remember, from the first page, I squared is equal to -1. You need to make that substitution. So this is equivalent to 27 times -1, which is -27. And that would be our answer. Okay? If we had multiplied underneath the radicals before we figured the square root, and which would mean that we're putting the multiplication step before the exponent step. But if we multiplied these together, we would end up with a positive number underneath. When we took that square root, we would end up with positive 27, not the -27 we should have. Okay? So it really is important that you do this step first. Okay, so let's talk about some complex numbers. Okay? Complex numbers are numbers that can be written in the form a either plus or minus bi. Okay? A is called the real part. It's going to be a real number. And b is called the imaginary part because it has the I on it. Okay? Complex numbers must be written in this order. It is very picky. The real part needs to come before the imaginary part, which is going to feel weird because when we did polynomials, the variable came before the constant, but complex numbers are backwards. Okay? Also, we must split up any fractions. So you'll see what I mean by this. Okay? So basically, I could have 3 plus 4i. That makes sense. 3 minus 4i. -3 minus 4i. -3 plus 4i. All of these are okay, but we could not write 4i minus 3, which is very tempting. It's just not going to be in the right form. Now, the reason that people get so picky about this is that all the computer programs that deal with imaginary numbers have you enter the real part and the imaginary part in this order. So if we don't write it that way, then we end up messing everything up. Okay, so how do we deal with complex numbers? We're going to talk about adding them, subtracting them, multiplying them, and dividing them. In a lot of ways, we treat the I like a variable, and then we deal with simplifying that at the end. So we generally add the same way, we subtract the same way, we multiply the same way. If we end up with I to a power, we're going to have to simplify further. Now, the division is it's going to feel familiar to something else, but not like just dealing with a variable. Okay? So let's try adding 7 plus 15i plus -11 plus 14i. The parentheses are here so that you can see that we are adding two complex numbers. We have a real part and imaginary part, real part, imaginary part, and we are adding them together. Now, because this is addition and we're going to treat these like they were polynomials, it doesn't matter. Technically, we're distributing a 1 on both of these, but this is going to be the same thing as 7 plus 15i plus -11 plus 14i. Let's gather like terms, remembering that we want our variable to come at the end because it's a complex number. 7 minus 11 would be -4. 15i plus 14i would be 29i. You want to double check that you have this written in the correct order. We have our real part first, our imaginary part second. Make sure that we don't have an I squared anywhere and that we really have gathered everything we can. And we have that. So this is our answer.